Algebra 1, here are your notes for 12.9, Day 1, Solving Rational Expressions. So first off, what is the main difference between simplifying and solving? Well, simplifying usually results in an expression. It usually doesn't give us an answer, whereas solving results in a solution. For example, something like x equals 4 would be a solution, while x plus 3 would be an expression. We don't exactly know what x is, we just know what it is in the context of other numbers. Whereas x, in this case, when we're in a solution, we know exactly what value should go in for x. So when solving equations involving rational expressions like we've been doing in the previous videos, the first question we should always ask ourselves is, are there any values for the variable that I have to exclude? And we've talked about these a little bit, but in the book specifically, they're called extraneous solutions. So I'm going to go ahead and give you an example right up. If I have 1 over x, what is a number that I can absolutely never have in the denominator of a fraction? So, in this case, what can I not have for a number in x? Well, we know we can't divide by 0, so in this case, an extraneous solution for this problem would be x equals 0. We saw in one of our other videos as well that if I have something like x plus 4, the easiest way to find an extraneous solution is to set the denominator equal to 0 and solve. In this case, my extraneous solution is negative 4, because if I plug in negative 4 to the denominator, I get 0, which we know can't be true. So let's take a quick step back and solve some of these. We're used to these. 8x minus 3x is 5x. It equals 120. Divide both sides by 5. And I get, anyone know their division right off the top of their head? No? All right. 5, let's do 12. We get 2. Ooh, struggling for a minute here. 24. Yes? Well, 5 times 20 is 100. Yeah, 24. Ha! Had a brain fart moment. Thanks for bearing with me. On the right-hand side, we have 8x plus 8 equals 10x minus 10. Remember, we're going to combine across the equal signs, so minus 8x over here. That cancels this. If we add 10 over here, that cancels that. And we are left with 2x equals 18. And x equals 9. Pretty simple stuff, but the reason I showed you that is because when we jump down here to solving equations with rational expressions, we have to do just that. So first it says solve. We know that we need to get these to have the same denominator, but as I've shown you in another video, there's one way when we have something equal to a number that we can cancel out both of the denominators in one go if they're both numbers. In this case, we're going to find their least common multiple and multiply by that. The least common multiple of 3 and 4 is 12. Now, why did I do that? Well, when I multiply 12 into all three terms, it's another way of simplifying. 12 times this is going to be 24a over 3, or just 8a, because 24 divided by 3 is 8. 12 times this second term is 12a divided by 4, or minus 3a. And 12 times 10 is 120. So by just finding the LCD, I have now turned this into a problem that has no fractions, and I can solve it the exact same way that I did this one. 5a equals 120. As we saw before, 120 divided by 5 is 24, and there's my answer. However, I do have to double check, are there any extraneous solutions? In this case, are there any values that I could plug into the denominator of any of my fractions that would cause any problems? Since there are no variables in my denominators, the answer is no. Now that's how we solve when there's two fractions on one side. What about when you have a fraction equal a fraction? We should remember from our earlier days the method of cross multiplication. Multiply top down, we get 8 times n plus 1. We set it equal, and then we multiply bottom up. 10 times n minus 1. Top down, bottom up, set them equal. Because doing this is very similar to this step, because they both result in one line that I can now solve the same way that I did before. Notice how this problem turns very quickly into this problem simply with cross multiplication. All right, same thing. Minus 8n here, plus 10 there. Those cancel. 2n equals 18, n equals 9. However, this time we're not quite done. While this is a perfectly good answer, we have to make sure there's no extraneous solutions in the denominator. What are two values that would make these 0? Well, the first one is n minus 1 equals 0, telling me that one extraneous solution is 1. The other involves this n plus 1 equals 0, making my second extraneous solution negative 1. When it says state the extraneous solutions, I'm going to go ahead and do that right here by saying that n cannot equal negative 1 or positive 1. Even though it's not circled, it is part of my answer. All right, let's jump to the back. We've got a ton of examples back here, but before I go on, I do want you to give these a shot. Use the examples that we just did together. And when you're ready, come on back. We'll walk through them together. All right, hopefully you had time to pause the video, try these on your own. Let's go through them and see what we get. This first one, very similar to the first example I did. I noticed right away with these two fractions that they only have numbers on the bottom. So I'm going to go ahead right away, and I'm going to multiply by the lowest common multiple, which in this case is 6. By doing that, I get 6x minus 18 over 3. When I reduce that, this becomes a 2 on top and a 1 on bottom. So I get 2x minus 6 over 1. We want it to be over 1 because that is what gives us one line to work on. 6x over 2 becomes 3x. So plus 3x, I'm taking this symbol. Equals, remember if I did it to the first two terms, I also have to do it to the third term. So 6 times 4 is 24. Now it's all on one line, and I can just simplify. 2x plus 3x is 5x. I'm going to add the 6 over in this step as well. I get 5x equals 30, and therefore x equals 6. Do a check. Do I have any denominators that could possibly have problematic values? No? So there's my answer. Next one. Whenever we see a fraction equals a fraction, we know that we're going to cross multiply. This arrow goes top down, this arrow goes bottom up, the equal stays in the middle. So 12 times x plus 2, equal stays in the middle, 4 times x plus 5, and now it's all on one line, just like that. 12x plus 24 equals 4x plus 20. We're going to simplify. I'm going to minus the 20 here. That cancels. I'm going to minus the 12x here. That cancels. So in this case, I'm left with negative 8x equals positive 4. Divide both sides by negative 8. I get negative 1/2 because 4 over 8 is 1 over 2. That is my answer or my solution to the problem, but I do have to do a quick check for extraneous solutions. What two numbers could I plug into those denominators that would potentially cause me problems? Well, if I do my quick solving method, x plus 5 equals 0, one extraneous is -5, one extraneous is -2. So those are the two values that x cannot be. Let's keep going. This one says, first state any extraneous solutions and then solve. Hey, guess what? Doesn't matter what order we do it in, we're still going to get the same answers. I check my denominators. There's no extraneous solution, so there's nothing I have to be worried about. I notice I have two fractions, both with numbers. So let's find their lowest common multiple. It's 20. So 20 times x minus 5 over 5, those reduce to just be 4. So 4x minus 20 over 1 plus 20x over 4, the 20 and the 4 reduce to 5, so plus 5x equals 8 times 20, which is 160, all on one line. 4x and 5x is 9x, minus 20 is 160, 9x equals 180, divide both sides by 9, we get 20. As I said before, there are no extraneous solutions, so that's my answer. I love cross multiplication so much. I think it's super fun. So I'm super glad that there's more of these problems. Top down, x times x minus 5 is x squared minus 5x equals, bottom up, x squared minus 25 is equal to, or is multiplied by 1 is just equal to x squared minus 25. Cool thing about this, when I minus my x squared over, boom, both of them cancel. I have negative 5x equals negative 25, and I get x equals positive 5 as my answer. However, did you catch the mistake I made? I get so excited about cross multiplication that I didn't follow directions. It says first state any extraneous solutions, then solve. I was like, nah, gotta solve it, got too excited. So even though I did it wrong, let's go back and double check. Are there any solutions that would cause problems? Yes, there is. In fact, when I solve this one, when I move that 25 over and take the square root of both sides, I actually end up seeing that my extraneous solutions are negative 5 and 5. And then when I solve this one, 5 is already taken care of. So right here, it's already taken care of. So when I write that down, you're going to notice very quickly that one of my extraneous solutions is the solution I found. Therefore, there are no solutions. See, this is what happens when you get too excited about cross multiplication. Even though 5 looks like it should work, it breaks the laws of math and we have no solution. Boom. Okay, here's my redemption. I have another cross multiplication, but I'm going to follow the rules, don't worry. First, we're going to state the extraneous. So I've got x equals, what number won't work here? Boom, 0 is the really easy one. X minus 6 equals 0, meaning positive 6 would be our other extraneous. And from there, cross multiplication. X minus 3 times x minus 6 equals x times x minus 3. Time to FOIL. X squared, that'd be negative 9x plus 18 equals x squared minus 3x. The x squareds cancel, which is really nice. And then in this case, I'm going to move the 9x over. So I'm going to have 18 equals, when I add that, I get 6x. Divide both sides by 6, I get 3. 3 does not conflict with either of the extraneous solutions or values that I found. So there is my final answer. All right, I know that was super fun. If you have any questions, don't hesitate to let me know. I would love to talk about it more.